Hey guys, today I'm going to be showing you this Santa hat here. Why am I showing you a Santa hat, you may ask? Well, this one has lights on it. This actually has a RGB LED strip just kind of stuck onto the fur here on the hat. And I actually made this thing, so I'm going to go ahead and kind of show it off, show you what I did here. So first off, this is common anode RGB LED strip. This is the 50/50 size, so it's a little bit brighter than the standard, whatever it is, like 35/28, I think. But common anode, so these things you hook up positive to this one pin, and then you switch the negative on and off onto the three colors. So that's how that is, and it's white, which is nice because it matches this. Kind of like that. And on the ends of this, you may notice, well, it's going to come up with a gap. The way that I fix this is just to take the this part here and just pin the thing so that it covers up the gap that's left there. On the ends, I went ahead and just hot glued this stuff down to make sure the ends don't peel up. The rest of the strip is just held down with the adhesive that's on these strips when you get them. So anyhow, on the inside, because of course we need circuitry to drive the LEDs, I've got this little 3D printed box here, as well as 3D printed clips that hold in one of these USB power banks. Now, the reason why I chose to use a USB power bank is it gives you a nice constant 5 volts, which we need to power the microcontroller, which is in this little box. Now, the other reason why I like this thing is it's cheap. It's only about $8. It's rechargeable. It's got a fairly high capacity. This is 3,000 milliamp hours or so it claims. But it runs this hat for like 8 hours. So that's fine. The one thing you might be screaming right now is this thing puts out 5 volts. That LED strip needs 12 volts. How the heck am I doing that? So the way that that's getting done, this little board right here, this blue one. Let's see if I can get in closer. This board on here is actually a boost converter, and you notice I managed to find one on Amazon that has a micro USB port on it. So I can just plug in a standard USB cable and plug that into the power bank, which is quite handy. Now, I will note, you can crank this all the way up to 12 volts with no problem, but you're only going to get like 2.5 hours of battery life, but your hat will be ridiculously bright if you do that, which is kind of neat. So, I have this set out about 10 volts on the output, which is a compromise in between brightness and battery life. And over here, I have an Attiny 85 microcontroller. Now this is kind of special. You do need the Attiny 85 because the program that's in here does take more space than what the Attiny 45 has. So, other than that, the only thing on here, there are 3 standard NPN bipolar junction transistors. Those are 2N2222s. I mean, like a 2N3904 would work the same. Doesn't really matter. And just the resistors on the bases of those. So there's that. This is the bottom of that little case there. If the camera would focus on it. It's not doing a very good job there, is it? But this is all just kind of press fit together. But I made little standoffs in the bottom corners of this, so the board just kind of rests in there, and I ended up mounting a capacitor on the back of this board, which needed that to smooth it out a little bit better. Smooth the voltage, since I'm using PWM on the LEDs. Kind of had to smooth the voltage out a bit. So anyway, those little standoffs, you just hold the board up in the air like that. And I made a little slot over here so the wires will come out there. And this just holds the board into place, as well as it kind of helps the wires stay in there like that. And this will just slide into place and press on there. Kind of awkward to do with the camera in front of you though. There we go, and on the front of this is a hole where the micro USB cable will plug in. And these two little clips right here, I'll zoom out a bit more, are used to clip in the power bank. Now I align these things with a bit of felt, and that's in order to give them some grip on this, because when these were just plastic, I kind of stuck this in here and it fit fine, but it was pretty loose, so there wasn't anything to hold the power bank into place, so I just put some felt around there, and now it holds onto this thing fairly well. And of course, it's not like it's really going to fall out of this hat, because if it's on your head. There we go. So in order to turn this on, we'll just plug the USB cable in here. And I'm going to go ahead and set up my camera to have a fixed exposure so we can see this a little bit better. And I'll be right back. Alright, so I've turned the exposure way down and I've dimmed the lights in here. Should be able to get some idea how bright this thing is given how dark the picture is right now. But I'll go ahead and plug that in. First thing we go through is kind of a fading sequence, and it kind of fades through all the colors there. Now, one thing to note about this is the Attiny chip really only has 2 PWM outputs, and well, normally the Arduino IDE only recognizes it as 2 outputs, but it's been set up in the code to where it will run 3 outputs. Is how this. I found the code on this online, and that first little bit you saw just came from online. There's a code that was already written for that, and now this part is where I started to write the code and make it longer and make it do some more stuff. So have red, green, and blue just kind of fade in and out here. Then we go into just individual colors, and they just kind of flash on. Well, they flash on for half a second, and they flash on for 1.5 seconds, and they're off for 1/4 of a second. So. If anyone's interested in the code, I'll leave a comment on the video. I'll make that available. I'll probably put a comment down below the video to put the code. I think there's 477 lines of code on there, so it'll be pretty long. But you just copy paste that out of there. Alright, then we restart from the top with the code again. So hopefully that gives you some idea. Really, the camera is going to be screwing up the color no matter what. I noticed just on the LCD screen of the camera it looks a lot more white than it does in real life. So I apologize for that. But anyhow, let me turn the exposure settings back to normal, and I'll talk a little bit more about this thing. Alright, so anyway, this hat makes a heck of an attention getter. Unfortunately, one of my 3D printed battery clips here actually cracked as soon as I actually put this in, so I don't really think I made these things thick enough, but it does still at least hold the battery decently well. And I think for the most part these parts came out fairly nicely, the 3D printed parts. I'll just give you a better look at the circuit board since I didn't really fairly simple wiring, really. All it is running the output pins from the Attiny microcontroller over to a resistor, then into the transistor there. Now, the capacitor, I noticed it's not really necessary per se, but without that, because I'm using PWM, these LEDs are pulsing on and off really quickly and drawing pulses of current instead of just being on steadily. And the boost converter on here, as well as the power bank, we're making 500 hertz whining noise. And that's another thing I should mention about this. If you're going to do this with your Attiny, make sure that you have this thing set up so that it has an 8 megahertz clock instead of the 1 megahertz clock. And the reason why you want to set this up for an 8 megahertz clock is because the PWM runs a lot quicker when this is set to 8 megahertz. I think at 8 megahertz I measure is about 500 hertz. At the default clock speed of 1 megahertz, the PWM only runs at about 60 hertz. So, and you can really notice the flicker at 60 hertz. And actually, even on camera, this thing looked okay with the 500 hertz or so PWM that Attiny chip is putting out. So, alright, so I figured I'd give you a look at the code here, and I'll go ahead and show you a little bit of how this works. But up here we're just declaring a whole bunch of integers and variables there. This sets up this here as well as this part. That sets up for the PWM on 3 different pins instead of just 2 of them. So that's how that is, and this declares the pins. I don't know which ones they are. So most of this top part here, as well as this, I got from another online source, which I'll link to in the description of this video. That is, if I remember or can find it again. Anyway, this void set color basically just calls this port up here. Then this part as well came from that code because it was just an example. And then I went ahead and put in this else statement, which this is like sets up a delay, and then that sets the color to 0, or it turns everything off, and well, it turns everything off for a second. And then we start going into this Rgb Fade Routine, which is this part, and it'll set wait to 0 so it doesn't go back to this delay routine, because you don't want to have it turned off for a second every single time this loop runs. So then we go into this, and it will just add to the brightness or subtract if it hits this statement here. And after this happens, you notice this flag equals 1 pops up. Then we go if flag equals 1 and the brightness equals 0. So in other words, if it's gotten all the way to the top of the brightness and all the way back down, then we're going to say go ahead on the green fade, make sure the red doesn't start again, reset the flag, reset the fade amount, because this will have turned it into the negative fade amount, or -1, because fade amount just equals 1 in this case. And then, just in case, make sure that all the LEDs are turned off before we go into fading on the green. And it just does that again for the green, does it again for the blue. And then I set this so that this red fade value equals 2, and it ends up doing the same thing again, so it fades red, fades green, fades blue. Then this whole thing is under a delay of 15 milliseconds, so if you want to speed that up, you could change this, or slow it down, you could change that. And at the end of this, we go to this other colors statement. And this, well, first off, turns everything off. And then we just set red full brightness, turns it off. And It just goes down this and it sets a whole bunch of different colors. It does it 3 times. Then at the end, it goes back to this fader equals 0 and RGB fade equals 0, weight equals 1. Basically resets everything to where it starts out as. And we start back up here. So anyhow, that's it for now, guys. Bye.